Hello, my name is Marcus Kirikit. This is assignment 2 for Com 3132, also known as machine learning course. And for this one, I'm going to briefly showcase the code. So upload the data set from Iris, import pandas, right? And then import sklearn, train test split module from sklearn. And then we're going to import TensorFlow. And then from TensorFlow, we're gonna import sequential and dense model for this question. And for 9, we just did a simple we just define a model in sequential. We're gonna compile the model and then fit it and then evaluate it with accuracy and loss. And now I'm going to answer this question right here. And how does the number, and I'm going to answer this question right here. How the number of layers or hidden units could impact the accuracy of our model. So the number of layers and hidden units affects how well the model learns patterns. More layers or hidden units can improve accuracy by capturing complex relationships, but too many can lead to overfitting, where the model memorizes the training data instead of generalizing well. On the other hand, too few can cause underfitting, making the model too simple to learn effectively. And do we always suffer from overfitting? No, not always. Overfitting happens when a model learns noise instead of general patterns, but it depends on the dataset size, model complexity, and regulation methods used. If we apply techniques like dropout, early stopping, or data augmentation, we can prevent or reduce overfitting. And how can we detect overfitting? We can detect overfitting by comparing training loss and validation loss. If the training loss is low but validation loss is high, it means the model performs well on training data, but poorly on unseen data. We can also use learning curves to visualize this, or use early stopping to track validation performance. And we can reduce overfitting using dropout, which randomly disables neurons during training to prevent the model from relying too much on specific features. Other techniques include early stopping, regularization, data augmentation, and increasing the dataset size if possible. Now I'm going to change each of the following settings that are chosen in number 9. So here, I'm going to change the optimizer. So define a new model, call it model underscore opt, short for optimizer. And here we have a optimizer called Atom. Instead of RMS prop, I'm going to have a model called Atom. And here we have an accuracy of, I'm going to evaluate this model. And here we have an accuracy of 0.8 and a loss of 0.8. And here we're going to change the number of layers. So instead of, so we're going to, so for this one, we're just adding one more hidden layer, which is this one, model 50. Just adding another hidden layer here. And the accuracy of this model is 0.833 and the loss is 0.2940. And we're going to, for this one, we're going to change the hidden units. So instead of 100 here, we're going to change it to 50 here. And we're going to evaluate this model here. And we have 0.8667, 0.440. Change the number of epochs from 10 to 20, from 4 to 20. Here, we're going to evaluate again. We have 0.967, loss of 0.203. Change the batch size from 10 to 20. And here, we're going to evaluate it again. So we have 0.633, and our loss is 0.5667. So this really shows that that changing any of these settings from number 9, the optimizer, number of layers, hidden units, number of epochs, and batch size can result in different accuracy loss, different accuracy and losses for each model. So that's it. That's it for the assignment. Thank you for watching. Have a good day.